Today we're looking at servos. Servos are found in model aircraft, in robots, in radio controlled cars and all kinds of places. They're a kind of motor that has a little digital controller built into it, and you can set them at an angle, and there are continuous rotation servos that rotate 360 degrees, whereas the usual servos that you see around, they go from roughly 0 to roughly 180 degrees. Fortunately, Arduino comes with a simple servo library, and that's what we're going to use today. So in the first example, we're just going to run one servo and command it with serial. So we include the servo library, we tell it to use pin 9, and wherever there is data available on the serial, we set the angle to whatever integer is available on the serial. We wait for a new line, and then we set the servo to that angle. Very simple, just type in whatever angle you want and the servo will respond. In the next example, we're controlling two servos, and this is just to show that that is possible. Now, got to keep in mind we're using tiny little servos that come with the Arduino kits, and they don't draw a lot of power. If you were to use a beefier servo that draws more power, then you couldn't power it off the Arduino power pin. You would have to use external power. But these tiny servos, you can get away with powering two tiny little servos this way. So we're going to put one on pin 9, the other on pin 11, and we set up two servos using the servo library again. We set the pins to output, we attach the pins to servo 1, servo 2, and then all we're doing is swinging them backwards and forwards, delayed by a second. And even though these are alternating, they're actually synced up when you look at my breadboard, so I'll show you that now. And this is the example we're building towards. We're going to control two servos, but with a joystick this time. The addition we make to the sketch is we add an input for the X coordinate and an input for Y. So the way these work is it's like a little potentiometer for one direction and a potentiometer for the other direction. So if you move both directions, so at an angle, you're moving one high and one to the right, and then if you do the reverse, you're moving it low and to the left. So the X and Y can control two servos. So again, we've got servo 1, servo 2, and we're using the serial this time to output the reading so you can see visually the coordinates that are being sent back. We're using the X as input, Y as input. We read X in, and we read Y in from those analog pins, and then we're outputting it with a comma in between with a carriage return after the Y. And then because what we get back is the analog with 1024 possible values, 0 to 1023, we have to map it to an angle 0 to 180. Now, as I said, it's not exactly 0 and it's not exactly 180, it's probably around 5 to 175 or something like that, but for our purposes it'll be fine. Then we do a small delay.